All right, kia ora. Here is the first remote task for week number 8. I know this week you will be allowed on site. Each year level has their own day. So since you guys are year 13s, you will be on Friday. So with Friday, it's only going to be a 45-minute lesson. So obviously that won't be enough to give a full week's worth of content, and you're still at home remote learning anyway. So I figured I should give you guys some tasks to do, especially as in to kind of work up towards being able to see you on Friday. Just so some notes for what to kind of expect on Friday. And also in the following weeks. The plan is that for week 9, we will be back to normal on-site teaching. So schedule as expected, everybody there, all the year levels, that sort of thing, to give us 3 solid weeks of material before you guys go on term break. The way I have looked at the schedule, we will probably need to continue organic chemistry into term 2. So there won't be... or it's unlikely that we'll have any sort of chemistry assessment this term. I might give you a section of a test or those little CPR quizzes. We'll see how it goes and how you guys are feeling. I've also discussed with the other science teachers, and we've decided that for this first practice exam, we will allow you guys to bring in a cheat sheet into the practice exam. It needs to be an A4 size, and it can be double-sided. So if you want, you can start creating that little cheat sheet to bring in when we do our practice test for this organic chemistry, which will take place sometime in term 2. So just wanted to give you FYI on that. Let me just make a note of what time I said that so we can move on. I'm trying to put little timestamps in our videos. 2:16. All right, so now let's actually start with the content. So first thing in our task for this week is I want us to finish up those organic chemistry techniques. So that's going to be one section of this lesson. And then the second section of this lesson is looking at conversion of molecules. This is a really common type of question for the organic chemistry exam. So if you remember with organic chemistry, I said there's not really any clear-cut categories of questions like thermochemistry. Instead, there's lots of little kind of consistent sections of questions that they chop and change and move together. The main key thing to remember with all of this is that that flow chart is really important, because you need to basically know how all the organic molecules interrelate to each other, and you'll see this in different format questions, either in the isomer questions, which we've just looked at, and we'll do some more looking at a bit later once we've covered more function groups, and also conversion from one thing to another. So let's have a look at that. So our learning intention for today, or I should say success criteria for today, is looking at that ability of processing various bits of information to fill in a flow chart, or just to explain that conversion of molecules. And then also you should be able to identify when you want to use certain organic chemistry techniques. Again, these questions chop and change each year, and sometimes you may not see that question one year and it will be on another year. So I do need to cover it just in case, because we don't know what combination they're going to give us. All right. So one of the questions you're going to get on this assessment is creating a specific compound. Basically what they're going to do is they're going to ask you, if I have this organic molecule as my starting molecule, what do I need to do to get to this other molecule? And basically the question is, can you write your steps explaining how to do that? The other thing that might be included, it depends on the question. Some just want you to explain how would you do the conversion and what reagents you'll need in order for that reaction to occur, aka the flow chart's really useful. Other questions will also integrate in another layer where they're going to ask you about what equipment do you need to use and why. So that's what this focus on is for the second half of the organic techniques. In the first lesson, in the previous lesson, we learned about some of the organic chemistry techniques, such as distillation and reflux, and now we're going to learn a few others. And you have seen one other one that was mentioned with the sodium carbonate. Cool. So here is my little slide for all the different techniques. I've just taken this off of No Brain Too Small. Normally what I would do is I would print this and annotate it. Unfortunately, I don't have a printer at home, so I'm just going to grab a piece of paper and do some drawing. I won't go through in great detail of the ones that I've already done. So distillation, you guys have already seen with the aldehydes, in order to remove the aldehyde and prevent it from being going through the second oxidation step to form a carboxylic acid. Distillation also is just used as a step of purification. So if you're writing any steps to explain how to do a conversion, your last step should then say, and then I'm going to do distillation to purify it, because it's the best way to purify anything, because you are separating things based on boiling point, and that's very unique to that molecule. So do kind of keep that in mind. What we have here is a separating funnel. So let me go to my document camera and draw what that looks like, and also an explanation on what it would be used for, or rather right this way. I'm trying to think. I think I've actually used this in the lab. It's not a terribly great way to separate, but it is something that we use. And I'm tempted to use my gel pens again because they're fun. And they make me happy as I am in isolation. I don't know. I hope you guys don't mind the gel pens. I like glitter. If I can't have my normal pens, I'm going to use gel pens. Cool. All right. So when you see a a separating funnel, what you will notice is a little kind of bell-shaped kind of flask with a little nozzle to control it. And I'm just going to draw it on a piece of paper real quick. And then a little funnel for collection. There we go. That's what I want. Go back to the document camera. All right. So that's what a separating funnel looks like. I'll write separating funnel. It's very similar to what you guys were using when you did titration. So if you remember with titration, you had that burette, and that burette was basically like a measuring cylinder that you tipped upside down. And then you had this little valve that would control whether or not it was opened and dripping. So what happens in this is that you have two liquids that are mixed together, and the important key thing about these two liquids is that they're immiscible. So they basically you have one that's like polar and non-polar. So basically like oil and water, they don't mix together. Now, obviously, I want to separate those two things apart. Actually, let me double backtrack. An example of when you would have this is when you are forming your tertiary alcohol into a tertiary haloalkane. If you guys remember in that example with Lucas test, one of the things you notice is that the solution forms two layers. And so and the reason why it's forming two layers is that a haloalkane is less water soluble than the alcohol, because you've lost those hydrogen bonds. So that would be an example. I do a reaction, and I have my watery mixture in the bottom, and I have my haloalkane on top. The less dense liquid is on top. And this is the more dense. And so what happens is I open up the valve and I let the solution through into my collection beaker. And basically I stop the valve before I get to my second liquid. And then I can put another beaker down and then collect the second liquid. Now, obviously, this isn't an amazing way to separate solutions, because we're probably going to get a little bit of some of the top bit mixed in or some of the bottom bit's going to be mixed in. And so that's why we always follow up with a distillation step, because that just confirms that removal using boiling point. So do kind of keep that in mind when you're looking at things, that this is a component of the step, but this wouldn't be the final step. The reason why I want to still do a separating funnel is because it's more efficient for me to just do this step instead of taking this whole solution and putting it into a distillator when I don't need to. I can just take the smaller amount of the stuff that is, I guess, just each step you do is going to purify it a bit more instead of just chunking the really muddy, gross liquid straight onto the distillator. So yeah, that's that. I'm just checking times of things so that way I can note it when I post it, so it makes it easier for you. Cool. Now we're moving on to, I think I wanted this. There's another sheet I had on here. Let me pause. All right, sorry about that. I just noticed a page in my PowerPoint was missing something, which is fine. So, like I said, I took this from no brain to small just to kind of recap all the different techniques. We've covered the separation funnel. So now let's go to the next page. The next page has a bit more on there that you'll be mindful of. The first one, again, that you've seen before is that refluxing. So that one's not new. And with that refluxing, the main key reason that you're using this is so that way you can increase the yield of your product. You're basically heating it, and as you're heating it, vapors are going to evaporate, and then to make sure they don't get lost, we have the condensing tube to make sure it falls back down. It could also be important for things that require multiple steps, such as converting an alcohol to carboxylic acid. So you guys have already seen this one. Another one you've probably, hopefully, have seen at some point in your time in science is a funnel with a piece of funnel paper, and that is, again, to separate mixtures. But unlike the mixture with the separating funnel, these guys are not both in the liquid state. In this case, it's going to be something that has a precipitate in it, something that's solid that can then get catched by the filter paper. So do kind of keep that in mind. It's just to remove something that's solid. Very frequently, what the solid thing that you're removing is going to be this anhydrous salt. So whenever we do these chemical reactions, we add anhydrous salt towards the end, and that removes any excess water. Basically like the packets that you see added into chip packets and things, just to remove the extra moisture. That's what that's going to do. It's just a drying out agent, and because that is solid, when we then put it through the filter, it's going to catch it, which is really useful for us. So I won't draw that out because I think the explanation is fine, and you guys have probably seen this before. Cool. So those two are new for you guys. And then the last one is the addition of carbonate, which I believe I mentioned in the CPR quiz. Carbonate, as you guys know from level 1 chemistry, is a base. If I add it to an acid, it will bubble and form carbon dioxide. So it's a really good indicator for me. If I have, say, for example, the carboxylic acid functional group. The other reason why I add the carbonate is for neutralization purposes in this case. So when I'm converting from one molecule to another, a lot of the reactions will ask for acids as a catalyst. And you'll see that when you write it down, you need conc. So concentrated sulfuric acid. Obviously, I don't want that later down the track, so I'm adding the carbonate to it to neutralize any of the acid. Same thing if you're using carboxylic acids as one of your reagents. If there's any carboxylic acid left over, I want to neutralize it, so I add the sodium carbonate. Now, keep in mind when we do that step, there's going to be carbon dioxide bubbles, so you're going to release the valve while you're mixing and neutralizing it, so that way the carbon dioxide is allowed to escape. Normally, you would do this process of neutralization first, then add the androgenous salt to remove any water, then filter it out. And then depending on, what you might have, you might go and backtrack and then, your then next steps could be separating funnel and then distillation. It really depends on what you are trying to make. So that's what I wanted to show you as an ideas. Those are all the different techniques. And what I will do is start showing you these conversion questions. And with these conversion questions, I'll basically do two examples. I'll do one example that's just the straight, how do I get from one molecule to another? And then the second example, I'll show it integrated in with the equipment because it varies from year to year. Sometimes they just ask you to do the conversion. Other times they ask you to do the conversion and state steps in the experiment that you would do. Cool. I'm just taking a note at the time on the recording so I can put bookmarks in. So we're at 16:05 and we're doing 2009. Okay. Cool. All right. So I really, really, really enjoy these questions for organic chemistry because it really makes you think. It really makes you show if you understand what's going on and you can see that interrelation between each other. The other reason why I think organic chemistry is actually the easier of the level 3 chemistry externals is that there isn't a lot of writing. With this question here, you will be able to get up to the excellence level and you don't have to do a lot of writing to do that. The main things they're looking for is, can you tell me the conditions and reagents you will need and also the structural products after each step. So what we will notice in this question here, I'm just going to start writing it down on my piece of paper and then I can switch to the document camera, is that we're trying to commute butane on, which is a 4-carbon chain with a carbonyl on carbon number 2. And we're trying to convert it into butane 2,3-dione, which is basically a diketone. So I want to see a carbon on carbon 2 and carbon 3. So the question is, how do I add both of those things together? So the thing you need to kind of think about that I notice here in this case is that I have a carbonyl and I basically want to add another carbonyl to this molecule here. Now we know in order to get the carbonyls, we go from alcohols, in this case secondary, and we oxidize. And that's how we get to our ketones. So basically what I want to do, since I have one on carbon number 2, I want to take carbon number 3 and get a alcohol on it. Because if I can get an alcohol on carbon number 3, then that's a secondary alcohol and then I can oxidize it to a ketone. So I need to think about how do I get to that point. And it's actually quite tricky because I have to think about the reactions that I know. And in fact, we're going to have to undo a little bit of our work and then work forward. And that's the thing about knowing that flow chart, is how do I navigate it, because there's not always going to be a direct route. So when I look at this carbon here, I can't do just a clear substitution reaction of let's get rid of that hydrogen and put in an OH. It doesn't work that way. So I need to go, okay, what else can I do? If I think about how do I get to an alcohol, well, one of the ways I get to an alcohol is by hydrating an alkene. So when I hydrate an alkene, remember we are adding the hydrogen and we are adding a OH. So that's something that I can keep in mind, is that I can get from the alkene to an alcohol. But one of the problems with doing that is that I'm going to run into the issue of major minor, because I know that one is going to get the hydrogen and the other one's going to get the alcohol, and I'm still going to have the same problem of I'm just going to form another alkene that only has one alkene. Does that make sense? So what I want to do in reality is I don't want to necessarily hydrate it, but I want to add 2 OHs. So I do need to keep with that alkene model, but I need to have that addition reaction. Add OH to both. And I hope that makes sense to you guys. Because if I just add that OH to one, remember that when I do that substitution reaction, that elimination reaction, and I remove the OH, if I just take the OH from this alcohol over here, I need both OHs on there. So let me show you what I mean as a big picture, and hopefully that kind of thought process of what I was doing kind of gives you an idea. Something to kind of note is that these alkenes here are really good intermediate steps. So when I say they're really good intermediate steps, they're really good at converting. Functional groups. And the other thing that they're really good at is that they're good at moving function groups like around a carbon. So if I was thinking about this molecule, butanon, and I do a reduction reaction. Pardon me, I don't have my reduction reactions quite memorized. It was like sodium something. I'll check it on the answer schedule, but you guys would be better than me. All right, so then if I did that reversal, and now I've reduced it and I have that alcohol. That's great news, but the problem is I need to have another alcohol. So what I then do is I do my elimination reaction. And then I have to worry about major minor. Now, you're not explaining major minor in most of these questions. You just identify which one you're taking. So in this case, I want to remove this OH, and I want to remove a corresponding hydrogen from either side. So that way I can set it up to add back to it. So I don't want it to make that double bond between carbon 1 and 2, because I can see that these two carbonyls are between 2 and 3. So in fact, that tells me I want to have my double bond over here. So I will be taking the major product, and you will mention that in your writing. So that's why we reviewed major minor, but you don't need to explain major minor. So I take the major minor, and this is what I form. Like that. So that's my next step there. That is my dehydration, and that's my elimination reaction. And if I was a good chemistry teacher, I could remember off the top of my head what I need to do that. I think it's concentrated sulfuric acid, but we will check the answering schedule. And that's an example of like why you would need to neutralize it if I'm doing any sort of reaction scheme. Right, now here comes the tricky part. So I don't want to do a normal hydration reaction, because if I do a normal hydration reaction, all I'm going to add is one alcohol. It's either going to be added to carbon 2 or carbon 3. And either way, it's then going to go back to being a 2 hydroxyl. So I don't want that because I'm forming that product again, and then when I oxidize that product, I'm still going back to butanol. So it's not actually forming the new thing. This here now is my little trick. Can you see that yellow? I'm not going to use that yellow. That's not very good. Let's grab another color, maybe the black. So what I'm going to do is I'm going to oxidize it. And remember, you're going to need a really strong oxidation agent to do that. So specifically, you need permanganate. It doesn't work with the dichromate. And so what I then form is my diol. So hopefully you remember how I was saying I'm trying to get the diol, because if I get the diol, both of those will oxidize to form my diketone. And that's getting me down to my final product here. So we do another oxidation. This time you can use any oxidant. It's not fussed. So you can use dichromate if you wanted to. And you see how there's, like I said, all those acids are in there. You're going to neutralize them later if you had to give those sort of steps. And then my last product will be this, which is what I wanted. So yeah, like I said, with these conversion questions, there's not a whole lot of writing. There's just a lot of, can you figure out how to do everything? And that main trick was trying to figure out, what am I going to do here? The other thing I want to recommend is don't feel like you need to go forward. I have gone forward because I really know my chemistry and I know what I'm trying to do, but you can work backwards. And I encourage you to do that if you're not sure what you're doing. I mean, one of the main key things that you know going backwards is if I have a diketone and I want to think, how do I make it? Well, the first thing you need to do going backwards is I need a diol. Like, I can't form this without a diol. So I can start working backwards, and with that information, that might actually help me figure out, okay, what do I need to do to get this molecule from this molecule up here? So feel free to work backwards. Working backwards can really help. Don't feel like you need to go in any order with organic chemistry, because it just needs to be the order that gets you the right answer, because everything's interconnected. Let's look up the answer to this so we can see how the points broke down. So this is the level 3 chemistry exams. This is a great way for you to see how I find these answers, but you guys should know how to do it. Assessment schedules for level 3, and this was the 2019, I want to say. Yes, 2019, because I really like that question. 2019 organic chemistry. There we go. And you were, I believe, question number 3, if I was listening. There we go. Question number 3. So it says butane on to butane to all using, and then I'm going to write in the reagent because Miss does not have that reagent memorized for some reason in her head. B4H. Okay. Cool. And then here's the second one. Oh, I got that one right. Cool. And then, yes, that's everything that you need. So you see how I have it? It's just 4 steps. And the way you get your points for this is that there's not a whole lot of writing. So that's why I'm saying the organic exam is easier to get the excellence on. So for the cheat, recognizes 2 appropriate reagents is what they were looking to do. So for example, if we go back to the document camera, I could understand that, you know, I need to go backwards here. And in order for me to kind of go backwards, well, the forward reaction of what I'm actually going to do, that is going to be MnO4, my oxidant. So that is, you know, one of my reagents. And then you just got to think about a second reagent. So a second reagent you could have identified is this one here. I know I need to reverse this. 2 reagents you haven't achieved. So even though we haven't put the whole thing together, take a guess and write what you know. So if I have a dead end in my flow chart, I think, okay, how do I go forward? How do I go backwards? So yeah, with these 2 things, write, how would I reverse this? How would I produce this? You would get an achieved mark for that. So do take a guess. I've seen other marking schedules where if you're able to show 1 step in this reaction chain, they gave you an achieved point. Merit was 2 correct steps, including structural formula and reagents. Number 3 is that full kind of conversion from one to another. So I find that with this question, it's either you're going to probably get an excellence because you're going to know what you're doing, or you're really going to struggle with it and you're probably just going to get an achieved. That's how a lot of organic chemistry, I think, is with some of this marking schedule, especially for things like this. So do keep that in mind. But it is an easy question if you know your flow chart. So make sure you memorize that flow chart. Make sure you have flashcards, and just have a general knowledge of how I go from one to another, because that's basically all the organic exam is. All right, and then there was one more I wanted to show you. I'm just checking the time so that way I can note it down. So we're at 3:31, and I'll put in the next timestamp, and this is going to be another example. So this one here isn't actually an NCEA question, but this one is a good way of seeing a technique question. Normally their technique questions aren't this long as the one I'm trying to show you, but it could be because we never know what's going to happen with organic chemistry. All right, sorry this video is a little bit long. I am putting timestamps on there so you can flick through the chapters. All right, and this question here, it's just another way to do a conversion question. It's just a little bit fancier. So in this case, you are taking 2-chloro-2-methylbutane. We should always read the description, and we should read it as a full sentence. A description of the laboratory procedure that could be used for the preparation of 2-chloro-2-methylbutane from 2-methylbutane-2-ol. The reason why I read that out like kindergarten is because a lot of people make mistakes because they just assume this is what we start with and this is what we're making because they just look at it in sequence order. But from what the sentence says, we are actually starting with the 2-methylbutane-2-ol and then making the 2-chloro-2-methylbutane. So make sure you have that reading comprehension and that you're pulling the words and pulling the right reagents. I have seen a student on one of my mock exams misread the question and did the whole reaction going reverse, and I couldn't give him any points because it was just a language comprehension thing that he messed up on. So double check it. Luckily in this case though, they have given us the instructions, and so that will help kind of like catch if you made a mistake. Anyway, you are adding the 2-methylbutane-2-ol with the concentrated hydrochloric acid in a separating funnel, and you leave that for 10 minutes. What you are doing then is running off the acid layer and slowly adding sodium carbonate solution to the remaining liquid and then separating the funnel. Remember to shake the funnel and release the gas. That makes sense because we're forming carbon dioxide as it's neutralizing the acid. And they want you to discard the aqueous layer. Next thing they say, I always like to read all the instructions first because it helps me go big picture, and then we can also annotate it as well. Run the haloalkane into the beaker, add a few pieces of sodium sulfate, and swirl gently. Decant the haloalkane into a round bottom flask and distill. And then all of these follow-up questions here are asking you why you have done certain things. And also tying into showing, do you understand what's happening with this type of reaction? So I have seen these questions on the exam. They're not as frequent as the conversion question we just saw, but it could happen. And this is technically a conversion question with just the equipment integrated in. These equipment-based questions can integrate into the aldehyde, carboxylic acid, ketone questions. It can also integrate here as a conversion question. Anyway, so let's think about this logically. 2-methylbutane-2-O. That is my alcohol, and I see that there's hydrochloric acid in there. So what that's going to be allowing is a substitution reaction, and I am forming that 2-chloro-2-methylbutane that they mentioned before. They also mentioned down here that you have a haloalkane that's present, so it all checks with each other. That's what has happened. So that's what you know when you're thinking about writing the equation for this reaction and basically what you're forming. Next thing we're thinking about if we're going through, so we now know what the concentrated hydrochloric acid was. It's just to use as a reagent to allow for that substitution reaction. The sodium hydrogen carbonate. So even though we have a 2-layer and we're using that separating funnel and we separated out the aqueous layer from it and we closed the stopper and we just wanted to have the nonpolar layer on top, which has the haloalkane, it's not perfect when it does that. So there's still going to be a little bit of the hydrochloric acid that is in there. So that's why we are going to be adding that sodium hydrogen carbonate, sodium carbonate, and it's going to neutralize any acid and bubbles are going to be released. Now you have to remember with that equation, if I'm taking an acid and a base, one of the byproducts of that is water. So because of that byproduct of water, because there might be water being mixed in because of the reagents we've used earlier, we're going to add that anhydrous sodium sulfate, and that's going to collect it all up and kind of remove the water component, because I don't want to waste my time distilling stuff when I could remove them easily in other ways. In this case here, they've asked you to decant. So decant is just when you're very slowly just pouring off the top layer or something and leaving the solid inside the beaker. That's another way of doing basically separation with a funnel. That works too. So just be mindful, that's another way you could do it. And then lastly, they have that distillation set up, so that way we can separate it based on boiling point, and we have the thermometer here, so that way we can look specifically for the boiling point of the haloalkane, and thus we know when it's starting to come off and when to basically switch out the funnels, because you want to put the beaker in there for the waste stuff that might be boiling off first, then put the beaker through when you have the boiling point of the haloalkane just to collect that up. And then the moment the boiling temperature goes past the haloalkane, you're going to remove that beaker and put in another waste beaker. So that way, all you should have in the beaker is that haloalkane. Cool. All right. So I hope that makes sense. Cool, Kapai. So for today's lesson, you guys should know more organic chemistry techniques, and you should also know how to convert from one to another. Let me just look at the time. 37. I'm just going to write 37:20. So yeah, just to recap, that's what we were looking at, and that conversion. For today's success criteria, you should be able to start integrating all that information with the flow chart that we've covered so far. There are some functional groups that I haven't talked about yet, so we haven't gotten through the whole thing. But it's good to start looking at these ideas now, so that way you have more practice with it. Cool. So you should be able to convert a good chunk of the organic molecules from one to another. If you find any functional groups that you haven't heard yet, that's because I haven't taught it to you, so skip those questions. And the other thing you should do is be able to identify the different organic chemistry techniques and when you would need to use them. Cool. So that's it to me. So now it's time for you to go on to your Mahi choice, which is listed on my Google site. Remember, I don't expect you to do all of it. It's just differentiated and do as much as you need to feel like you understand the material and you get your gold grade. If you're feeling too overwhelmed with the choices, flick me a message and tell me where you are with the material, and I can give you something specific to work on. I know some people are a bit overwhelmed by choice, and so let me know and I can tell you specifically where you should go. Okay, cool. The next task then for this week is a CPR quiz. So nice and easy.